Hello, my third grade mathematicians. Today we're going to continue to work on fractions. We are learning to place whole number fractions and fractions between whole numbers on the number line. We're going to begin with our problem of the day. In your packet, it probably says application problem, so you need to work through this as we're doing it together on the computer. So let's begin by reading the problem of the day. Everyone ready, read. Hannah bought 1 yard of ribbon to wrap 4 small presents. She wants to cut the ribbon into equal parts. Draw and label a number line from 0 yards to 1 yard to show where Hannah will cut the ribbon. Label all the fractions including 0/4 and 4/4. Also label 0 yards and 1 yard. So first off, what do we know? Share with a friend what you know about this problem. Yes, we know that Hannah bought 1 yard of ribbon to wrap 4 small presents. We also know that she wants to cut that ribbon into equal parts. Now, what does it tell us that we have to do? We have to draw and label a number line from 0 yards to 1 yard to show where Hannah will cut the ribbon. We also have to label all the fractions including 0/4 and 4/4 and label 0 yards and 1 yard. So we have a lot that we have to do in this problem today. So let's start out by drawing a number line from 0 yards to 1 yard. So let's draw our number line. And let's label that number line 0 yards and 1 yard. Very important that we use the unit yards when we're doing this. Now we need to show 0/4. So at 0 yards, that fraction would be 0/4. And what would the fraction be at 1 yard? That's correct, 4/4. So we can also add the unit yards to each of those. Now we need to label all the fractions. So if there are 4 small presents, then we need to partition this number line into what? Yes, fourths. So we need 4 equal parts. So if this is 0/4, this would be 1/4, 2/4, and 3/4, and we already have those labeled as 0/4 and 4/4, and add our unit yards. Very good job. So we have just used this number line to show where Hannah will cut the ribbon. Very good job. Let's keep going. So we've already discussed that we are learning to place whole number fractions and fractions between whole numbers on the number line. So on the next page in your packet, you have a blank paper, and that blank paper has Eureka Math on the top of it, and we're going to use this just like you would use your journal in the classroom. So I want you to draw a number line on your packet with the endpoints of 1 and 2. So draw your number line, label the endpoints 1 and 2. So the last few days, our left endpoint has been 0. So this endpoint here has been 0, but now it's 1. Talk to a partner. Where has that 0 gone? Exactly, that 0 hasn't gone anywhere. It's still there. We're just not showing it on our number line because we know that 0 comes before 1. It looks like we took a picture of a piece of a number line, but we still know that we have those missing numbers. So let's partition this number line into 4 equal lengths. So we're going to put a tick mark there, 1 here, and 1 here. So now we have 4 equal lengths. So I have 1, 2, 3, 4 equal lengths. So our number line doesn't start at 0, so we can't put 0/4 there. It starts at 1 whole. So how many fourths are in 1 whole? Very good. There are 4/4 in 1 whole. So we're going to label this 4/4 and put a box around it to show that that is 1 whole. So if we have 4/4 here, we know this would be 5/4, 6/4, 7/4, and then we get to 2 wholes, which is 8/4. So let's put a box around that also. We call 4/4 and 1 whole, where those are equivalent. There are 4/4 in 1 whole, so 4/4 and 1 whole are equivalent. And 8/4 and 2 wholes are also equivalent. 8 divided by 4 is 2. 4 divided by 4 is 1. So let's suppose we had 3 wholes on this number line. So this number line extended, and it would have to extend farther than my screen, but it extended, and then there were 3 wholes. What fraction would be equivalent to 3 wholes? I know some of you already have that, so we'd have to partition this into 4 equal parts between 2 to 3. So this would be 9/4, 10/4, 11/4, and then 3 wholes would be 12/4. Very good job, those of you that figured that out on your own. Wonderful job. So let's keep going. Now, let's draw another number line, and this time I want you to draw a number line with the endpoints of 2 and 4. So 2 and 4. So what's missing on this number line? There's a whole number that is missing from this number line. Very good. It's the number 3, because 3 comes between 2 and 4. So now I want you to partition each whole into 3 equal lengths. So this is 1 whole. Sorry about that. So this is 1 whole, and this is 1 whole, and we need to partition them into 3 equal lengths. So we have 3 equal lengths there, and we have 3 equal lengths here. So 1, 2, 3, 1, 2, 3. So if we have 2 wholes and we have partitioned it into thirds, we know that the fractional unit is thirds. And we know that how many thirds are in 2 wholes? There are 6 thirds into 2 wholes. 6 divided by 3 equals 2, or we can count by 2's 3 times. 2, 4, 6. So there are 2 wholes that are equivalent to 6 thirds. So let's keep going. 7 thirds, 8 thirds, 9 thirds. So there are 9 thirds in 3 wholes, 10 thirds, 11 thirds, 12 thirds. So there are 12 thirds in 4 wholes. So 6 thirds is equivalent to 2 wholes, 9 thirds is equivalent to 3 wholes, and 12 thirds is equivalent to 4 wholes. All right, I love the way you all are working. Now let's do one more. So this time we're going to label our endpoints of 3 and 6. So we have 3 wholes and we have 6 wholes. So what is missing? What whole numbers are missing between 3 and 6? Perfect. 4 and 5 are the whole numbers that are missing between 3 and 6. So if you will look, you will see that I equally spaced those as best I could. So they have to be equal lengths, those whole numbers. So now we're going to partition each whole into halves. So from 3 to 4, we're going to have halves. So we have 2 equal parts. From 4 to 5, we have 2 equal parts. From 5 to 6, we have 2 equal parts. So if I have 3 wholes, and I know my fractional unit is 2. I know that if I count by 2's 3 times, I'm going to get 6. 2, 4, 6. So I have 6 halves, 7 halves, 8 halves. So 8 halves is equal to 4 wholes. 9 halves, 10 halves. So 10 halves is equal to 5 wholes. 11 halves and 12 halves. So 12 halves is equal to 6 wholes. So we have shown our equivalent fractions, our equivalents there, the fraction that's equivalent to the whole. Very good job. Okay, let's do some guided practice. If you'll look at the first one, it's been done for you. This first one, the fractional unit is thirds. So it is partitioned into thirds, 1/3, 2/3, 3/3, 1/3, 2/3, 3/3. And 1 whole is equivalent to 3/3, 2 wholes is equivalent to 6/3, and 3 wholes is equivalent to 9/3. So let's look at B. B is, the fractional unit is eighths. So if our fractional unit is eighths, we know that our denominator is going to be 8. And we can count by 2's 8 times. And if we count by 2's 8 times, 2, 4, 6, 8, 10, 12, 14, 16. That gives us 16 eighths. So 16 eighths is equivalent to 2 wholes. So let's partition then it's into eighths. So that makes halves. Halves those again. Now we have fourths. Now we can partition again. And now we have eighths. So we have 16 eighths, 17 eighths, 18 eighths, 19 eighths, 20 eighths, 21 eighths, 22 eighths, 23 eighths, and then for 3 wholes, we have 24 eighths. So 24 eighths is equivalent to 3 wholes. If you would like, you can continue and do fourths by yourself. I know you can do it, and you will do a great job. Okay, you can also work on this problem by yourself. Finish that one, take a picture, and send it to me, and I will see how you did. So in your packet, after this page, you have a problem set. So you're going to complete all of the problem set on the front. And then on the back, you have a choice. You can choose one problem to do on the back. Very good job, boys and girls. If you need me, please call me, and I will help you do whatever you need help with.